Today's presentation title is Wildlife Resource Protection on Traveled Federal Lands. Your presenters today are Angela Kochowiak, who is a research scientist with the Road Ecology Program at the Western Transportation Institute. She has almost 2 decades of conservation-related experience, and for the past 5 years, she has been actively engaged in a wide variety of projects on wildlife transportation interactions. She currently serves as the ARC Technology Transfer Leader to share the innovations that emerged from the first ever competition of its kind. Rob Ament is a Road Ecology Program Manager at WTI as well at Montana State University. He has more than 25 years of experience in plant ecology, natural resource management, environmental policy, and organizational development. Tony Clevenger is a senior wildlife research scientist with the Road Ecology Program at WTI as well. He specializes in identifying factors influencing wildlife crossing performance and analyzing factors contributing to wildlife vehicle collisions. Sandra Jacobson is a wildlife biologist at the USDA's Forest Service Pacific Southwest Research Station. She provides technical expertise and training on the interactions of highway and wildlife for federal and state public land managers and the transportation communities across the nation. And without any further ado, I will hand over the presentation to Angela.
Thanks, Amber, and good day, everyone. It's a pleasure to share this time with you, and I'm looking forward to an engaging discussion about wildlife resource protection on our traveled federal lands. Before I get started, I just want to remind everyone to mute your device at your computer. I was hearing some little background noise. That might be distracting for some folks, so I just wanted to make that little reminder. Okay, so we all know that federal lands are more than beautiful terrain, water, and vegetation. They form a network of habitats that support wildlife. And we tend to think of parks, forests, grasslands, and refuges as being prized areas of nature, protected from intrusions of full-blown urbanization. But chances are even relatively remote jurisdictions still offer travel by road. My co-presenters, Rob and Tony, will be speaking about the tools, techniques, and more of the solutions to wildlife transportation issues. But to set the stage, I'll be providing a brief overview of the challenges that wildlife populations face when living near or attempting to cross traveled roads. There are 4 main ways that roads and traffic impact wildlife populations. Rob's section will mostly deal with number 2, vehicle collisions, and Tony's section will hit on all 4 of these impacts. And perhaps coincidentally, perhaps not, several of these might look familiar to you as key priorities for federal agencies in that they focus on resource protection and transportation. Despite their usefulness and arguable necessity, once a road is there, it becomes something to be managed. And it's a challenge to keep negative impacts to resources at a minimum. Every road building effort affects the suite of species that once relied on that plot of ground. New edges are created with different temperature and moisture regimes and other environmental variables that affect habitat quality for hundreds of meters in some cases. Every road represents habitat lost and some degree of decreased habitat quality. This is a given, but it's easy to forget as soon as you start cruising down the road. But the regular maintenance and use of roads can also affect habitat quality. Chemical additives, while making for a better ride, can impact wildlife. Stormwater runoff can carry polluting substances from cars and maintenance activities to nearby waterways, which can affect aquatic organisms and then those animals that feed on them. In the winter, road salt can attract birds and other animals to the road surface, leaving them vulnerable to collision, and it's been documented that ingesting road salt can itself cause fatal toxicity in birds. In dry months, dust palletizers applied to unpaved roads can attract animals interested in minerals. Again, this could make animals vulnerable to collision, but not much is really known about the potential toxicity of dust pilotates on wildlife, since that research is still in its infancy. And no less important to mention are the influences of artificial light and chronic noise. Sensory pollutants can upset natural rhythms and biological processes. And even when alternative modes of transportation are used, the road still needs to be maintained at a certain environmental cost. The second main way wildlife is affected by roads is by collisions. And because it's a pervasive problem for a wide variety of animals, I'd just like us to take a moment to get on the same page that countless animals are struck by vehicles every year. And we may never know how many because they often go unreported or nobody's counting. Or even if someone is counting, things can get complicated very quickly because of scavenger bias and searcher bias. So here's an example of searcher bias. So let's see if you could spot the roadkill in this picture. It's easy to miss even if you're looking for it. Okay, here it comes. I'll let you see that again. Well camouflaged carcasses such as this one or those far away from the road can easily go unnoticed. Usually, unless it involves a species of conservation concern, road mortality is dismissed as an issue. There are some examples, though, where roadkill is a documented threat to the very existence of a population or even a species. This is from a report that we at WTI conducted for Congress, and it's listed in the literature cited section for you at the end of this webinar. And you can see that mammals, reptiles, amphibians, and birds are at risk from this source of mortality. Now, note that there are other factors such as habitat loss that also impact these species, and that a substantial reduction in wildlife vehicle collisions may not automatically result in viable populations, but still, road mortality is another threat that needs to be recognized. So vulnerable or isolated populations notwithstanding, the number of wildlife killed by cars can be mind-boggling, as is shown here by these statistics. Okay, so here's a little pop quiz for you. Can you guess the estimate for how many vertebrates, mammals, birds, reptiles, and amphibians die on U.S. roads per day? So cast your vote if you would. I'll give you a second to do that.
Okay, Angie, I'm going to close the poll and show the results.
Okay, it looks like most of you are pretty optimistic, estimating about 300,000, 600,000. Okay, Amber, if we can go back to the presentation. But if you guess D, 1 million vertebrates are estimated to die on U.S. roads per day, then you were right, unfortunately. Recent research highlights the significance of vehicle strikes of smaller animals. The excerpt, the first top one relates to reptiles and amphibians, and the bottom one relates to birds. And I'm not sure if that anyone has even tried to estimate the number of invertebrates that are killed by cars or their turbulence, but that would really boggle the mind. And suffice it to say, roadkill estimates are just that, estimates. It sounds like somebody's having a party. I just want to remind you about your mute function there. But we may never know how many animals really are killed by vehicles. And does it really matter? Does it matter if animals are killed by motorists traveling through your park, refuge, forest, or grassland? That's a question for you and your agency to ponder. The third main way wildlife is impacted is by limited access to resources. So roads help us get where we want to go, but from the wildlife point of view, roads can represent an obstacle from getting from point A to point B, whether it's to access resources or mates, to migrate, disperse, or meet some other biological requirement. Some roads may be physically impossible for some animals to cross due to concrete median barriers, for example. Tony and I did a project a few years ago looking at various barrier types that are used along roadways to prevent or reduce head-on collisions. On the upper left, you see an example of a metal beam barrier. They typically range from 27 to 34 inches tall. On the lower left is a cable barrier. In the center, you have a concrete barrier, sometimes called a Jersey barrier, and they're about 32 inches tall. But they can be as tall as 59 inches tall if you're talking about the Ontario tall wall. And sometimes concrete barriers have scuppers in the bottom that allow drainage and opportunistic movement by little creatures. In the upper right, you have just a grassy median. And in the lower right, you have rumble strips that are carved into the roadway. So when a driver veers out of his or her lane, the vibration reminds him or her to be alert. We wanted to get some sense of the potential risk posed by these different barrier types. So we created 5 taxa or animal groupings, which are listed at the bottom, 1 through 5. And we assigned permeability scores based on the physical size and ability of each group of animal to overcome each barrier type. And this was independent of potential traffic mortality risk. We viewed potential permeability in absolute terms. That is, whether an animal could traverse, climb over, or crawl under a barrier given enough time. That is, if it was in a field versus on a road with a car bearing down on it, for example. And then we assigned colors to represent relative permeability. Red indicates no to low permeability, yellow indicates moderate permeability, and green indicates high permeability. So if you look at the Ontario tall wall, the second one in the list on the left, at almost 5 feet tall, it likely allows no or low permeability for all taxa groups. While the metal beam, cable, centerline rumble strips, and the vegetated median, the last 4 on the list, they're rated high for all taxa groups. So from this exercise, we see that the small to mid-size animals, groups 1 through 3, may be most affected by barriers to permeability. And this was a qualitative analysis, and it was not intended to be a guideline, but rather a starting point for discussion about potential impacts of median barriers. And whether or not there is a barrier type infrastructure per se, sometimes traffic itself is enough to repel animals from crossing a road. And let's not forget about water flowing under a road. So in this schematic, water is flowing from right to left through this culvert. And this schematic is showing you the potential impediments that fish and other aquatic organisms face when trying to swim upstream through a culvert that's put to allow water to cross under a road. And imagine yourself as a little fish here in this pool down here. And you're trying to swim upstream, but the distance from the pool that you're in to the culvert might be too great. Or maybe it's not that the distance is so great, but you might not have enough depth in your pool to get sort of a running start to get up in there. Or even if you were able to get into the culvert, what's the water like in there? How turbulent is it? Is it just puddles? Do you have to flop from one to the next? And even if you get to the outlet, then what kind of debris might be built up there? That's also going to act as an impediment. The impacts of roads are not only recognized by individual researchers, but the National Research Council on the National Academies have also looked at the issue. Bringing us to the fourth main way that roads and traffic impact wildlife populations: fragmentation and isolation. So if we take a moment to zoom out from the road itself, we can see that roads can disconnect local populations. On the left, let's assume we have a robust population of your favorite wildlife species. Most of the subpopulations represented by the different circles are able to interact through dispersal and genetic exchange, for example. On the right, though, a road might prevent dispersal of individuals across the road, leaving its subpopulation isolated from the rest of the meta population. And the connections between populations then become fewer, and subpopulations might even disappear, as is shown by the X's there. Large mammalian carnivores are vulnerable to road effects because of their great mobility and extensive spatial requirements for survival. But small taxa with patchy and localized distributions are also vulnerable to the fragmentation effects of roads. So these were the four main ways that roads and traffic impact wildlife populations: reduced habitat and habitat quality, vehicle collisions, limited access to resources, fragmentation, and isolation. So you might be asking yourself, what can one agency do to mitigate the effects of roads on wildlife? So, if we look from examples from Washington State across the country to Florida, there are examples of FLMAs that are working side by side or have worked side by side with DOTs. In Washington, the Snoqualmie National Forest, for example, is working with WashDOT on the I-90 reconstruction project to benefit all wildlife that live in the corridor. Big Cypress National Park in Florida in years past has worked to reduce panther roadkill mortality. And I'm sure there are other examples out there. And we welcome you to highlight your examples of FLMAs that have made a difference when it comes to wildlife and roads. So if you'd like to share, don't be shy. And you can share your brief story along with any questions that we may have, which is coming up right now in our Q&A section. So, Amber, do we have time for some questions?
We do. If you have a question, you can use the Q&A drop-down manager to type in your question, and I will moderate it to Angie. Or if you'd rather speak to her directly, you may press *8 on your telephone keypad if you're joining us via the telephone. It does look, Angie, like we have a couple of questions so far, and the first question is, why are so many birds killed by cars? Don't they just fly over the road?
Well, there's a number of factors that might draw birds close to the road surface. There might be attractants like fruiting plants or carrion or road salts or insects. They might be flying from low-lying vegetation on one side of the road to the other. In the case of the barn owl in Idaho, it's not really known why as many as something on the order of 650 birds are killed by cars per 100 kilometers per year. There is some research coming out that suggests that body type or wing loading might make certain species more vulnerable to collision. But unless there are canopy birds flying long distances or soaring overhead, I guess it's just like for us, where the ground is where the action's at. And there have been some successful mitigation examples of encouraging birds to fly higher, and there's been some evidence of birds using wildlife overpasses too.
Great. And there was another question. Somebody basically stated that they don't get much traffic on their roadways. They're unpaved, and they've never seen any roadkill. How do they know if they have a problem?
That's a good question. I guess without evidence, it can be difficult to know. Perhaps your traffic volume is so low that the presence of the road surface itself only affects the smaller species movement-wise. Edge effects may influence predation and other biological processes, and I guess the only way to really tell is to conduct research comparing roaded and unroaded habitats, but typically in areas that have wildlife transportation interactions, there usually is some evidence, either in the form of roadkill or frequent crossing sightings. But in some instances, the road might have already impacted the neighboring community of species to the point where certain populations can no longer exist.
Great. And we do have a couple more questions. Is there a correlation between roadway width and design and the degree of the barrier that the road possesses?
I don't know the answer to that question. That would be something to look into. I'm not sure if that has been studied or not yet.
Okay. And the last question, how much more effective safety-wise is the Ontario tall wall versus the regular Jersey barrier? It seems to be an excessively high wall for animals, as well as people wanting to see across the road for sightseeing reasons.
Yeah, you know, I'm sorry to know the answer to that question. I became familiar with the Ontario tall wall when we did that median barrier report, and we were more looking at it from the wildlife perspective. But that is a good question to look into to see, you know, does a concrete barrier have to be that tall to prevent the head-on collisions that it's designed to prevent?
Great, thank you, Angie. And we do have a few more questions, but we're going to save a few of them to the end and hand over the presentation to Rob.
Thank you. Good morning, everyone. I will be talking today about wildlife vehicle collision data, standardizing it, and what you can do once you get good information. This was out of the national study, and Angie had mentioned the 1.5 million wildlife vehicle collisions. Those are primarily data kept with the large mammals, deer, moose, and elk. And those collisions are causing about 200 fatalities across the country, quite a few injuries each year, over 29,000 per year, as well as a lot of costs are associated, direct costs are associated with these wildlife vehicle collisions. So what do we need to do besides focus on the top issue, which is areas of safety concern, which is wildlife vehicle collisions with large mammals? We also need to identify where our roads are creating mortality sinks, maybe for amphibians or reptiles. We know sometimes species such as salamanders will do mass migrations between vernal pools and across roads. So we want to identify those as well. Sometimes our traffic volumes are getting so high that they're creating potential barriers for different species. So we want to also get good data that helps us find out where roads are becoming barriers for wildlife movement. And then also we need to know where there are successful movements across roads, where there is currently permeability, so that we maintain that. And as we know, this whole issue of wildlife vehicle collisions is always a front page story. I was just talking to my sister yesterday, last night, and she lives in Illinois, and she said there was a big story about wildlife vehicle collisions in her local paper. We tend to see this every year as the insurance industry sort of does a summary. This is primarily State Farm Insurance, and they sort of list the worst states. And if you look at those 5 states, it really shows there's pretty broad geographic distribution in this issue, from the east and West Virginia to the Midwest to the 5th highest state, or tied for 4th with Iowa's Montana in the west. So it's basically an issue nationwide. I suspect you probably are wondering where your state or your land management unit sits within this issue. So what I've done here is just, I want to give you a few moments on this next slide to see where you sit. This I peeled off of the website from State Farm. Last year is the most up-to-date information. As you'll see, Hawaii is the lowest, not many large mammals there, so wildlife vehicle collisions are only 1 in 13,000, greater than 13,000. And West Virginia still tops the list or bottoms the list, depending on how you look at it, and 1 in every 42 drivers is likely to have a wildlife vehicle collision. So I hope this has given you time to see where you sit in between 1 in 42 and 1 in 13,000. And when those are all added up from a national perspective, this is from the report to Congress on wildlife vehicle collisions. You'll see two graphs here. The top graph is all crashes, and the 15 years of data that we analyzed, it's been fairly flat over that 15-year period, where it's a little over 6 million crashes per year by all causes. However, if you look at this is the same national database, and if you look at the component that are animal vehicle collisions, you'll see they've gone from 200,000 up to around 300,000 in that 15-year period, so about a 50% increase, and that 300,000 of 6 million is about 5% of all crashes in the U.S. right now are animal vehicle collisions. And I just want to point out that I'll use the term wildlife vehicle collision and animal vehicle collision in my discussion here. Animal vehicle collisions include wildlife vehicle collisions as well as domestic animals such as horses or cows. So some databases include the domestics, and so we call those AVCs. When we parse through that information, what we find, this is from that same national study in the same database, the General Estimate System, we find that most, nearly 90% of all wildlife vehicle collisions are occurring on the two-lane highways and roads in the United States, way greater, or a greater percentile than about half of all crashes. So we know that two-lane highways are a big issue when we're trying to mitigate for wildlife. We also know from this data set that it's the low-volume roads, so nearly 50% of all crashes are on the lowest annual daily traffic roads in the U.S., and then 20% are in the 5,000 to 10,000 average daily traffic. So nearly 70% of all wildlife vehicle collisions are occurring on the two lowest categories of road volume. While if you look at overall crashes, those six-lane, or I'm sorry, the real busy highways that are getting 35,000 or greater is where a large percent of most crashes are, except for the wildlife vehicle collisions. So to summarize, we know where federal land managers should be concerned are two-lane low-volume roads. That's where most of the wildlife vehicle collisions are occurring in the U.S. We recently have been able to finally get a cost analysis around this. And Marcel Hauser also works here at Western Transportation Institute and led this, worked with an economist to come up with a summary of the direct costs, and you can see that each crash with a deer on average is about over $6,000 per crash. Because elk are a larger animal, bigger weight, they cause more damage, more injuries, and more fatalities on average. So they're $17,000, and then moose really top this off at over $30,000 per average crash with a moose. So we finally have been able to, that's how we have been able to estimate the $8 billion per year when we start adding up all the crashes by species in the U.S. Now this is just an illustrative graph here, but now that we know what it's costing on average per crash, we know what it costs to mitigate, to reduce those crashes. In this example, it's using underpasses with fencing. And we know what the crash rates, if we collect good data, we know what the crash rates are. And you can start seeing where you have break-even points, where the cost of the crashes and the cost of the mitigation are factored in. And for this example, if you have 3.18 deer per kilometer per year, you can pretty much justify the expenses for an underpass and fencing and jump outs. So that's we've only been able to do that for the last couple of years to help managers make tough decisions with limited resource dollars. And to make those good decisions, the other thing we are really trying to move forward, because it's not being practiced right now, is standardized data collection. It helps us with our crash rates or how many incidents we have. If we get good data, we'll be able to differentiate if things are changing up and down the road or times of the year, because you may want to go out and just put seasonal signs up along the highway when species are migrating, for example. Or you would want good data to figure out exactly where the best investments are to mitigate for permeability for wildlife on roads. And lastly, once you have mitigated, it's good to collect post-construction data so that you can develop measures of effectiveness of the mitigation measures. So basically, good data leads to making good decisions. And this is this is just one example of a federal land management agency, the National Park Service. We published this in the Journal of Environmental Management. But we did a survey of all the NPS units in the country. At the time of the survey, there were 388 units. Of those, 196 we determined had public roads on them. And so we sent the survey out to those 196, and as you can see, N equal 106, we got a little over a 50% response rate from the roaded national park units. But the reason I'm throwing this slide up is that what it's showing is only about half of those that responded, half of the park units, are collecting road mortality data within their unit. And then the other thing we asked them was, were they collecting data to see if the roads were causing fragmentation of habitat, affecting populations? And as you can see, only 11, or about 10%, of those that responded said they were collecting data that way. So we know there's a big challenge for most agencies and state DOTs as well on collecting good standardized data. And so what we are developing is this system of roadkill observation collection system to improve and standardize the animal vehicle collisions, and AC is animal carcass data collection. So the AVCs are primarily by the law enforcement agencies or maybe park rangers, for example. The animal carcasses, the dead animals being removed, are primarily by the maintenance crews that are collecting the information as well. A lot of this information today is being collected on paper and being warehoused rather than entered each year as we've talked to different agencies. So we do want to collect good, reliable information and data. This system will be easy to use. We're in the 4th phase of its development. We make it so that you can quick look at your data on your personal computers. It's also automatically stored, so different agencies can share out of the same database once you're granted access. And I will just show a couple quick examples of, if you collect good data, how you can do a spatial analysis and now a cost-benefit analysis as well, now that we have those numbers. So this is what the original unit looked like with the personal digital assistant and the GPS unit plugged in on top. These are all the sponsors of this, which are Federal Highways, Federal Lands Highways, the Deer Vehicle Crash Pool Fund, which is the 10 state DOTs, as well as Washington and Virginia. So there's a very broad interest in getting good information and developing this system. This is now what's being used. It's a much more rugged handheld unit. Everything is pull-down menus, and we can load the species list in for particular purposes for different units or agencies. And then the last thing we're doing now is creating a free phone app, smartphone app, because those units are 1,500, and when we realized for agencies to deploy broadly that it was effectively, the cost was becoming prohibitive. So we're trying to get that same system, because smartphones have such good GPS. All the data is within 3 to 5 meters instead of the old mile marker system. We're trying to get the app going this year. And this is what it would look like if you came to the ROCS website to go look at some of your data. You'll see this is each of these bubbles are where we had a test unit collecting data. You can go to the website and use the filters. You might want to only look at data from a particular year or a particular species, and it will sort it for you. And then you can export it and take it back to your personal computer out of this central server. And this is what a bubble, when you click on one of these data bubbles, you'll see that this particular one has 6, and you can find out it's all deer. One was an unknown, whether it was muley or whitetail, but that there were the 6, and then you can zoom in the next slide from that bubble and pick an individual observation and get other particular information about the date and time and sex and the species. The nice thing about the system is not only is it on just roads, you can have a terrain mode, very similar to what like Google Maps would be doing. So you can see if hot spots or high collision areas are where a drainage crosses a road segment, etc. Or you can also use satellite imagery if you're looking for wetlands or vegetation types. And lastly, I want to just give you an example of this was one of the field test areas in central Iowa, and you can see they had over 100 data observations in less than a year. And what you can do once you start collecting the good data is some people say, well, Iowa's flat and pretty much all road segments are the same. But what we did was we did a cluster analysis, and the red spots are where the highest 20 percentile, the top 20% of the crashes are occurring in those red spots. And if a red spot had something in the next percentile, 20 percentile, adjacent to it, we added that on. And so you can see that instead of having to mitigate the entire system of highways through this particular landscape here, you can actually pick your places where you're going to invest those limited dollars for mitigation. And then you can also look at that cost benefit. Again, this basically took a 25-kilometer segment of one of those highways in Iowa, broke it up in 100-meter segments, and then looked at the costs that were occurring due to crash rates, and then the costs of the mitigation. On these examples, it's an animal detection system, a detection system with fencing, underpasses and overpasses, or just underpasses. And you can start seeing where you can justify mitigating, from 50 to 150. From this point to this point would be a good place to invest mitigation to reduce wildlife vehicle collisions. And then the last thing I would like to talk about is not only can the agencies yourself collect data, but more and more they're becoming web-based data collection systems where you're involving citizens and building awareness at the same time as you're getting good data collection. And it builds support for things you might want to do to mitigate that particular road where you're having problematic areas. The other nice thing about citizen involvement is that they collect not only where roadkill is occurring, the dead species on the side of the road, but also where they're observing live. So you're getting areas of the road that may potentially still be passable and safe for wildlife to cross. And then you're getting more accurate estimates because your data sets are increasing in numbers. These are just some examples. Washington is for I-90, just a highway segment. Alberta is also Highway 3, which is a road segment. but the Massachusetts website is for the entire state, and Idaho was for a particular project, and that site's been pulled down now. But basically, these sites are showing up all over the country. I know there are other states like California has a statewide, Colorado has a I-71. So involving citizens might be another way of getting good information on where to mitigate for wildlife. And these are some of the signs that are driving citizens to those web reporting sites. The one in Idaho, that no longer exists, but we did get a very good response from citizens in that research project. And Colorado's ongoing on I-70, and you can see what an impact that makes on people when they're driving into the mountains. So at this point, that's the end of my presentation, and I guess I will answer any questions folks have.
If you have a question, please feel free to type it in the Q&A drop-down manager, type in your question, and I will moderate it to Tony. Or if you would prefer to speak, you can press *8 on your telephone keypad, and that will signal us that you have a question that you'd like to ask yourself. I do have one question. I think it might be for Angie, and it is, how strong is the correlation between posted speed limits and wildlife collisions, and could a change from 55 to 45 miles per hour make a significant difference?
Is that for Angie or for Rob?
I think it might be for Angie.
Okay.
I was thinking that it might be better for Rob. And I was going to ask Rob if he remembered if that was addressed in that report.
It wasn't addressed in the report, but it has come up, and what safety engineers have found is that people follow the speed of what the road is engineered for, not what the posted speed limit is. And so they're doing some things to fool drivers to slow down besides just having posted speed limits. And that is they like narrow the striping on the highway. And if you feel like you're driving around a curve and you keep going outside the painted lines, then you slow down. And so that's a way of, all of these are mitigations called traffic calming. Sometimes you have speed bumps for real low speeds, but generally the posted speed limit, people really follow how fast they drive, as fast as the road will allow them to drive, unless, of course, you have really strong law enforcement around those posted speed limits.
And I could add to that on a research project that I worked with Marcel on when he was studying an animal detection system. The whole premise behind animal detection systems is, there are sensors out there along the road that detect whether or not an animal's there. It sends a signal to, say, a flashing light, for example, to indicate to drivers an animal is on or near the road. And so the whole purpose of that blinking light is for drivers to slow down. So, to increase stopping distance and just to increase awareness. So I think you can, from that, deduce that slower speed limits tend to give people a better chance not to end up in a collision with wildlife. And sometimes, I think in Marcel's report, there was like a reduction of just a couple of miles per hour can make a difference in reducing the number of collisions, but I can't give you exact numbers.
Great. And the last question that we have time for is, will the ROCKS application be available for BlackBerry?
Let's see. So there are 4 commercially available smartphone makers right now, and we only have funding in this current phase to do 1, and we've selected the Droid phones, not the Apple or not the BlackBerry or not the Microsoft. So those are the 4 we would, for universal use, we need to get to all 4 systems, all 4 softwares. But at this point, our engineers, our electrical engineers, think that the Android is the best way to go for the first smartphone application.
Thank you, Rob. All right. I know there's some more questions, and we'll certainly try to get to them as we go along. And I'm going to hand that presentation over to Tony.
Okay. Thanks, Amber. Good morning, everybody, or good afternoon to everybody, depending on where you are. In this part of the webinar, I'll be discussing not only the importance of maintaining connected habitats and wildlife populations across roads, but getting into some of the practical aspects of planning, design, monitoring, and evaluating the performance of crossing structures. And Angie earlier covered the impacts of roads on wildlife, and because we'll be covering issues of habitat connectivity, I wanted to talk about how populations of wildlife are affected by this fragmentation effect of roads. On the left, we see a continuous population, and this is really the ideal situation for wildlife population, and probably how most populations were at the time of European settlement, easy interchange and easy movement within the population. But most populations today consist of what we see in the center. These are metapopulations, and that is that they're typically fragmented by natural or non-natural causes, but they rely on movement and interchange among the subpopulations within this larger metapopulation. And on the right, when we see populations become severed by high-speed highways or other major obstacles or barriers, they become disconnected, smaller in size, then therefore they're more prone to local extinctions. So keeping these habitat connections intact is important for the long-term viability of wildlife populations. And these connections can be viewed in two different scales. A large landscape scale, the map on the left, is the Yellowstone to Yukon ecoregion, where efforts are being made to ensure that populations are intact and connected over a huge area, over 3,000 miles. But for the Y2Y efforts, or the vision of Y2Y to be successful, it's entirely reliant on the ability to mitigate highways within the ecoregion using wildlife crossing structures, as shown on the right. And this is where the role of federal lands can have a huge impact on promoting secure habitat connections, not only where you work and the lands that you manage, but at a much larger geographic scale. So by mitigating at the local scale, you can have basically big impacts at a much larger scale. So the integrity of the large corridor network is totally dependent on whether these local site mitigations, the mitigation actions, are effective across roads. Now let's go back to the main impacts of roads on wildlife that we heard about earlier, and by far the two most important are traffic-related mortality and barrier effects of roads. So what I'll show you here is how these really and ultimately affect the viability of wildlife populations. So going through this flow chart, starting on the right with barrier effects, this can be a physical barrier to movements or a behavioral barrier where there's sensory disturbances from traffic noise or other road disturbance, and this could discourage movement across roads. The barrier effect reduces landscape connectivity, and thus it reduces the size of wildlife populations and their ability to persist over the long term. On the left, when animals are killed on roadways, this results in loss of individuals in the population, so the population size is reduced, but it's also a barrier effect because the animal didn't cross the road, and it results in one less member of the population. So considering these two effects, mortality has a much greater and more immediate effect on the long-term persistence of wildlife populations. Complete barrier effects would take many generations to manifest harmful genetic effects. So mitigating road effects on wildlife is good. It makes good ecological sense, but it's not the only solution in our toolbox of measures. We can avoid sensitive habitats, mitigate the impact, or compensate for the impact on habitats or species of concern. So here's an example where we have habitats of concern, where they've been identified as potentially impacted by a road project. Avoiding the habitats is quite simple. In theory, roads can go around and avoid impacts altogether. However, in reality, this is the least palatable politically and perhaps the least used option in our toolbox. Now, mitigating habitat loss or disturbance is certainly becoming quite common. Here would be an example of mitigating with some sort of wildlife crossing structures or animal detection system. And this is really what we'll be discussing from this point on, is mitigating with crossing structures. And the last option is compensating. It's another tool that's in the toolbox. It's more widely used as it relates to impacts to wetland habitat. The area or the extent of the impacted habitat is compensated by creating new habitat off-site or adding to existing habitat elsewhere. So the rest of this part of the webinar will be structured around mitigating roads using wildlife crossing infrastructure. First, where do they go? How do you determine where to place them? Second, what should they look like? Third, how do we monitor performance or use? Fourth, how do we determine performance goals are met? And last, what are some critical areas where we need more information? So first, placement and planning. When the agency objective is to mitigate for habitat connectivity, as opposed to just reducing mortality on roads, the location where one decides to mitigate road effects on movement should be within a landscape context. You don't want to create crossing opportunities that lead to ecological dead ends. They must connect to a much larger regional wildlife corridor network. So planning typically occurs in two scales. Project level planning here is centered and focused where the specific project is taking place, given stretch of highway, maybe 15 or 20 miles in length, that intersects with a migration corridor or an important crossing area for wildlife, or has been previously identified in a larger habitat corridor network. This doesn't necessarily require information from a much larger scale. However, if that sort of information is available, it should be used. And second, planning at the ecosystem level or the systems level, as transportation agencies refer to, consists of planning highway mitigation at a much larger spatial scale, such as an ecoregion, perhaps an entire state or province, or maybe even a large county. And planning at this scale uses data that identify where key habitat corridors are located. Then overlaid with the transportation network, we can see where the conflict zones are located and begin to prioritize mitigation actions based on species of concern and or short-term or perhaps even long-term transportation planning schedules. Now, 20 years ago, this would have been very time-consuming, but today, given the amount and the quality of GIS data that's available out there, it's a rather straightforward exercise and can be done in a short amount of time. Some of the planning data and resources that could be used consist of data on the road network, its location and proposed transportation projects, data on where roadkills occur, their frequency and changed over time, aerial photos, land cover vegetation maps, land ownership maps. For identifying wildlife habitats and corridors, wildlife habitat maps or suitability maps are used typically. For more localized decisions, having field data from specific research or wildlife studies is extremely valuable. And if that's not available, then models can be developed that simulate wildlife movements, which allow for identifying where these conflict zones occur between roads and dispersing or even migrating animals. And many of the resources mentioned in this last slide are available as GIS layers, in addition to those listed here, such as DEMs or digital elevation models, hydrological layers that map all water bodies, including streams, ponds, rivers, lakes, habitat suitability maps, built areas, and also the road network. When planning the placement of new roads, it may be difficult to avoid the key habitats, but the next best thing is to minimize their impact on habitats and wildlife populations. And we can do that by placing roads in areas that impact the least amount of habitat and wildlife movement. So this is just a schematic diagram of, on the right, where we have two potential road placements overlaid on areas of suboptimal habitat in purple and optimal habitat in this sort of orangish brown color. And the yellow lines are hypothetical movements of wildlife in meeting their biological requirements. So road placement in the right example, which bisects the key habitat straight down the center, will have substantially more impact on animal movements than the example on the left, where wildlife interactions with the proposed road on the margin of the key habitat is localized and reduced. So reducing potential interactions or needs for wildlife to cross roads should be a planning priority. Now on to how do we determine where crossing mitigation should go. Oftentimes agencies need to make decisions about where to mitigate in a matter of months. Maybe it's just 4 to 6 months. So this doesn't really give you a lot of time to carry out a full-fledged wildlife study targeted at determining where certain species are crossing the road, where these key habitat patches are. So like the planning resources that I showed earlier, fortunately there are a number of types and data and methods that can be used to help guide mitigation planning and decision making. Field data on where animals are killed on roads is really a basic first place to look, and as Rob mentioned earlier. However, relying entirely on where animals are killed on roads may not tell you where animals are able to cross roads successfully. We've been able to show from some of our research in Banff that the two locations aren't exactly the same. So it's best to supplement roadkill data with information on how and where animals move within the focus area. And observations of wildlife crossing roads or high-resolution tracking data from GPS-collared individuals can help pinpoint crossing areas. And areas with abundant snowfall are ideal for collecting road crossing data from winter road surveys. GIS-based models are commonly used today to simulate animal movements at a project scale and even a much larger landscape scale. And if there aren't any data available, then there are still some useful methods, including movement models developed from expert opinion, rapid assessments of crossing locations obtained from stakeholder meetings, and don't ever discount the importance of local knowledge and information from people that have lived on the land there in the area for decades. Wildlife crossing structures are static. They're not going to move. We can't pick them up and change their location after 5 or 10 years or 20 years. They're in place for their lifespan, which, like any bridge structure, is about 70 to 80 years. So how can we reconcile these permanent structures out there on the landscape with this dynamic environment that they're embedded, where habitats and species distributions change over time? There's two things to think about. One is that when planning crossing mitigation, we need to think not only about the species that are present today, but species that could potentially recolonize the area in the future through species recovery plans or other means. So those structures will need to be functional to those species as well. And second, when building multiple crossing structures, variability in design is important, so mixing large and small crossing structures, and this will provide assurance that most species needs will be met over the long term. Some basic principles regarding planning of crossing mitigation. First, topographic features. Mitigation should be placed where movement corridors are associated with dominant topographic features, such as riparian areas and arid areas, probably ridge lines and riparian areas. Second, multiple species. Crossing should be designed and managed for multiple species, unless there's a focal species of certain concern. Third, adjacent land management. Transportation and land management agencies need to coordinate in the short term and the long term. If federal land structure, then that agency needs to coordinate with the state DOT, and vice versa. If the federal agency is managing for regional scale habitat connectivity, it should be coordinating with the state agency about cross-highway mitigation. And last, the larger corridor networks. These crossing structures must connect to and be an integral part of a larger network and not lead to ecological dead ends. So I think at this point there's time for some questions if there's any out there.
There are a few questions, and I'm not quite sure who they're directed to, so if any of the three presenters will jump in, that'd be great. The first question is there data on how vehicle noises affect the likelihood of collision with animals? Are louder vehicles more likely to cause roadkill? Are there particular speeds at which roadkill causes collisions which tend to occur?
We don't, not particularly with regards to collisions, but we know that or specific cars and specific decibel output from trucks versus passenger vehicles and things like that. But what we do know is that typically on highways with greater traffic volumes, there's greater noise emissions from those highways, and it doesn't generally lead to increased road kills, but it results in habitat fragmentation. So basically there's this road effect zone where, particularly with sensitive species such as large carnivores, that they just don't approach some of these really, really busy highways. So it's not really a problem of roadkill, but it's more of a problem of barrier effects because of the disturbance from noise. And the second question was with regards to, it wasn't noise, what was Do you remember the last part?
Collisions?
Collisions. On busy highways, do you remember? Did you
It didn't indicate.
Okay. I don't recall the exact part of that question, but
And then next question, how strong is there a correlation for the placement of wildlife crossings to high quality habitats versus that of natural fennels and landscape-driven features?
oh, landscape what features?
Landscape-driven features?
Oftentimes they are the same. I mean, you can't really separate the two. Some of the riparian areas and areas which drive wildlife to or connect wildlife to important habitats are the same. So, and what we know about where wildlife move, where they need to move, those are typically the important areas for identifying where wildlife crossing structures should be placed. So, areas where highways bisect important habitats or important breeding areas, whether we're talking about amphibians, areas of refuge for certain species of large mammals. Those are really the most important things to be thinking about.
Okay, great. I think we can move on.
Okay. The next section is on the design of crossings. And crossings can be made of a range of materials, as you see here: rope, wire, pipes, concrete, steel. And we can divide crossings into two types: overpass designs and underpass designs. We've identified 11 types of crossings consisting of 4 overpass design types and 7 underpass design types. And these aren't designed for fish, but for all terrestrial wildlife, from voles and red squirrels to moose and grizzly bears. And so in these next few slides, I'll go over some of the designs and describe some important components. There's not enough time to go over all of the 11 different design types. First, wildlife overpasses. These are some of the largest crossing structure design types, with widths from 100 feet to over 300 feet wide. And the goal of vegetating these overpasses is to have the same type and the same amount of habitat on top as you have on the edges, or the habitat that they're trying to connect. The depth of soil can limit what type of vegetation grows on top. Obviously, the soils range typically anywhere from 3 to 6 feet. They could even be less than 3 feet if vegetating with shrubs and grasses, if that's really the primary objective. Earth berms are typically placed on the lateral edges to block traffic, noise, and lights. These are typically 6 to 7 feet high. However, if you had a solid wall, there wouldn't really be a need for the earth berms. And human use here is usually prohibited, since these are areas where human use or human disturbance should be minimized if you want to really encourage or try and facilitate the greatest amount of wildlife use. So human activity is generally restricted around these sites. We have wildlife overpasses. The large mammal underpasses, as you see here, are common among they're a common crossing mitigation measure. They're probably the most common crossing structure built today due to their ease of construction, the relatively low cost compared to overpasses, and the fact that they accommodate a lot of different wildlife species. They are designed for a variety of wildlife. They range in width from anywhere from 8 feet to over 40 feet wide, with vertical clearances from 6 feet to over 12 feet. And soil is generally placed in the inside of the underpasses to provide a substrate for travel. If the underpass is in a strategic position for wildlife use, human use should be discouraged or rerouted if possible. And small wildlife, small fauna need more cover and protection than large fauna, and this generally translates to adding brush piles, anything that you can find, brush and things like that, against the wall of underpasses. As you see here on the right, on wildlife overpasses, amphibian habitat has been created on top of overpasses. The one here you see here on the left, this is from the Netherlands, where the highway bisected wetlands on basically divided a wetland, and here they created sort of stepping stone pooled habitat that crosses the overpass and connects these wetlands that were severed by the roadway. There's many types and designs of small mammal underpasses consisting of tubes and culverts. These typically range in diameter from 1 foot to 3 to 4 feet wide or in diameter. It's important to have vegetation cover near the entrances for these structures to be used, and typically trying to get any sort of material, sort of substrate inside these things is almost impossible unless these things are box culverts and they're opened before they're actually completed. Canopy crossings, these are for arboreal or semi-arboreal species such as flying squirrels, red squirrels, pine martens. These canopy crossings haven't been used a lot, but they have proved to be effective where they have been placed. They are quite simple, they're low cost, easy to construct. The example on the left is from New South Wales in Australia, where they created a type of mesh tunnel or a tube, and they strung it across a motorway. On the right is an example from the Netherlands where they placed a runway made of wood, sort of a wooden trough, inside an existing signage structure. And then, as you see on the ends of that, at least on the sort of through the center of the photograph, you can see ropes, and these extend out from the ends of the trough out into the nearby trees. And perhaps the most difficult to design for is amphibian or reptile tunnel. Different amphibians have different sensitivities to light, soil moisture, humidity. Reasons it can be really challenging to design the right tunnel for their needs. As part of a technical handbook on planning and the design of crossing structures for the Federal Highway Administration, we prepared guidelines for the minimum dimensions and recommended dimensions of the 11 wildlife crossing design types for terrestrial wildlife. We divided wildlife into groups based on body size and movement requirements. This is an example of some of the guidelines in the handbook where we wanted to show here the dimensions and how they differ between minimum and recommended dimensions for a wildlife overpass and also a multi-use overpass, which has human use in addition to wildlife use. And these are the guidelines for 2 different underpass types. This part of the handbook is really more about how to design crossings based on the type of use they expect to receive, exclusively wildlife or mixed wildlife and human use. And you can see the different dimensions based on the type of underpass structure and whether it's for mixed use or exclusively for wildlife use. For species specific guidelines, we divided wildlife into 8 groups: ungulates, carnivores, low mobility, medium-sized mammals, semi-arboreal mammals, semi-aquatic, small mammals, amphibians, and reptiles. So for each of these 8 groups, we classified the suitability of each of the 11 crossing structure design types into the following categories: the recommended or the optimum solution, possible if adapted to local conditions, and this is where a large mammal underpass could be adapted for flying squirrel use. It's possible. The third one is not recommended at all for those particular species. Fourth is unknown, that is, there just really isn't enough data or research available to find out how a certain species responds to or uses, whether it would even use some of these different design types. And last is not applicable, so this would be, for example, bears using canopy crossings. In the guidelines, we also provided species-specific notes to help decision-making and to help best design a wildlife crossing structure for certain species or species groups. So once crossings are in place, it's extremely important that they be monitored and evaluated to determine how well they perform and what might be learned from the design. There are a number of ways to monitor wildlife use of crossing, but first it's important to clearly define what a successful crossing structure is. The question always comes up, well, how well does that underpass work, or how well does that overpass work? And there's really no general or easy answer to that question. It depends on the performance goals and also how one defines a successful crossing structure, whether it's one that is effective at reducing mortality, or whether it's effective at increasing habitat connectivity, or some combination of both. And it might be determined whether it's really focused on one single species, a target species, or whether we're talking about an entire wildlife community. So adding more species, wildlife communities, makes the answer more intangible and complex, and later on here I'll talk more about evaluating crossing structures. And really a stellar example of performance goal setting was done by WSDOT and the U.S. Forest Service for the I-90 Snoqualmie Pass East project in the Cascades. This section of I-90 bisects state, federal, and private lands. The project goals, however, were to maintain or restore ecological connectivity within this area impacted by the I-90 transportation corridor. Not just wildlife use, but ecological connectivity. And here they included not only terrestrial connectivity, which would be wildlife use, but also hydrological connectivity, so surface and subsurface water flows. And I think we have time for more questions at this point.
Yes, the first question is there a difference between crossing structures for particular species, meaning are underpasses better for some species and overpasses are better for other species?
Yeah, definitely there's species have preferences for certain design types. Typically species use all crossing structure design types, at least that's what we've been finding here from our research in boundaries, is that all species will use all different crossing structure design types, but there's definitely preference we find by grizzly bears, wolves, elk, and deer, moose also, to use these larger structures, not just the overpasses, but large span bridge underpasses, whereas black bears and also cougars tend to use these these smaller structures, so really the opposite of those. So that's why it's important really to have not just get it right on with regards to the dimensions of these structures, the minimum as well as the recommended, but also having a mix of those different structure types out there on the landscape if you're trying to mitigate a highway over a fairly large area. And I'll talk a little bit about that more here in the last part of my talk.
And Tony, why were there no examples that you provided in the United States?
With regards to stellar example, I did provide an example of I-90 as being an excellent example of where federal land management agencies have been working with the DOT to mitigate an important transportation corridor across the Cascades.
Okay, and the last question I think we have time for, how does route density play into travel planning?
Road density or route density? I guess you're referring
Route.
Yeah. Route density. A lot depends on the traffic volumes on these routes, whether you're talking about low volume roads or dirt roads or areas in more populated areas where we have high volume roads and really high density of high volume roads. So there's a whole spectrum of road density situations out there and how they impact wildlife populations. But I'm not quite sure how to answer the question or what the question is entirely, but by doing large scale statewide habitat connectivity maps, you can start assessing the impacts of road densities on different wildlife populations. That's probably the best approach, I would think.
Okay, great. And then one more question: are there minimum size recommendations for underpasses by species?
Yes, there are. In our federal highways guidelines, there are minimum dimensions for all those different crossing structure types, and it goes into detail about for each particular species that I mentioned there. And there is a species list in the handbook, how effective or what the minimum dimension should be for that particular species, for that crossing structure design type.
All right, great. I think we can move on. And there are a few more questions in our queue, but we'll save them for the end.
Okay, that'd be great. At this point, I want to discuss some of the monitoring techniques used to assess performance. On overpasses, given there can be wind, rain, and snow to obliterate tracks, two methods are typically used, remote cameras and rake track beds or sand traps. The latter is not entirely effective, given that rain and snow can remove tracks quite quickly. So most commonly, remote cameras are used today. If more ambitious questions or research regarding the number of distinct individuals and perhaps the proportion of populations that are using crossing structures, then some sort of a hair snagging method where DNA or genetic analysis can be conducted is typically used, and you can see that here on the right. This is we've actually used barbed wire, but any sort of method that can collect hair would be effective for this sort of technique. So for underpasses, it's really the same techniques as the overpasses: remote cameras, track beds, and barbed wire if more complex questions are being asked about population level benefits of underpasses. The track beds are really the cheapest and the most effective method at underpasses because they're protected from rain and snow. However, it does require that somebody be out in the field every 3 or 4 days to check the underpasses, to collect the data, and then rake the track pads. So there is I guess the added cost of being out there on a fairly regular basis, as opposed to cameras where you typically go out every 2 to 3 weeks and change the compact flash car to make sure the batteries are still working. State Route 260 in Arizona is an excellent example here of a federal land management agency cooperation with the state DOT to build wildlife crossings and invest in monitoring them over the long term. Arizona DOT worked closely with the Forest Service not only to get the wildlife underpasses built, but turn the monitoring into one of the most successful projects in North America today. The same is true on US 93 in Montana, where the Salish Kootenai tribe is monitoring over 40 crossing structures built by Montana DOT on reservation land. For small mammal underpasses and culverts, infrared cameras are commonly used, as are sooted track plates placed at both ends inside the culvert, and they're checked typically on a weekly basis. You can also use mark and recapture of individuals on both sides of a highway with crossings, and this will also provide information on individual movements through culverts. So now on to evaluating crossing structure performance. There are lots of ways to determine performance goals. They can be as simple as are animals using the crossings, to more complex assessments that might track how ecosystem processes such as predator-prey relationships, maybe rates of herbivory, how they may be affected by highway mitigation. Land and resource management agencies will have stiffer requirements than transportation agencies. DOTs typically are often content just to find that the crossings are being used. However, land and resource management agencies often require evidence of more complex ecological relationships, such as whether a species' biological requirements are being met, or subadults are able to disperse using the crossings, and populations being able to recolonize after long absences. And without a doubt, the area that's spent the most time pondering these performance questions is Banff National Park, where I've been leading a research project in the last 15 years. Banff is located in southwestern Alberta, approximately 70 miles west of Calgary. The Trans-Canada Highway here bisects the national park, running through the Bow River Valley. The TCH has been mitigated with 8-foot fencing and over 24 crossing structures since 1982. And these highway improvements occur when sections of the Trans-Canada Highway are expanded from 2 to 4 lanes. The first expansion occurred between 1982 and 1988. About 15 miles were widened and a dozen underpasses were installed. This section is called Phase 1 and 2. It's on the very right-hand part of the graph there. 10 years later, another 12 miles were widened, Phase 3A in yellow, consisting of 10 underpasses and 2 175-foot wide overpasses. And the remaining section, Phase 3B, is under construction today and consists of 21 more crossing structures, including 4 200-foot wide overpasses. And Banff is unique worldwide. It's nowhere do you find as many and diverse types of crossings on a single stretch of highway. Once 3B is completed, there will be a total of 44 crossing structures, 5 design types built over 3 distinct time periods. Along with it comes 15 years of continuous year-round monitoring of wildlife use of the crossings. Now, these are figures of the amount of use at the crossing since monitoring began in 1996. More than 200,000 species of large mammals using the crossings. These are the baseline data we use for conducting analyses to determine what factors associated with the crossings or their adjacent habitat influence used by different species. And we've done several analyses with the data, the multi-year data, and they show that species have preferences, as I mentioned earlier, for these different design types, even though that they can be found using all the types available. The grizzly bears, wolves, elk, and deer, and moose prefer using these large open structures, while black bears and cougars prefer the opposite, smaller, more constricted crossings. And these preferences really equate to what we know about how these species have evolved, either evolving in open habitats or closed habitats, and also their habitat requirements for travel. The histogram here shows the results of a comparison of the 2 overpasses in Banff versus the adjacent underpass and wildlife use there. It's basically a side-by-side comparison because the underpasses are within 200 meters, and it basically bears out the same findings as these previous multivariate analyses, and we find that there's predominant use of the overpasses by wolves and grizzly bears, as you can see there. Cougars prefer using the underpass when there's a nearby overpass, and black bears really don't care one way or another. And the question always comes up, do predators use the crossings as prey traps, and do they sit at the ends and wait for dinner to come strolling through? The answer is that there's really no indication that crossings are used as prey traps, and that's the result of an exhaustive survey of the literature that was conducted about 6 or 7 years ago, and also some recent work that we've conducted in Banff using 3 different types of data characterizing predator and prey species movements and predator kill site locations. Because we've monitored the crossings for so long, and a dozen right after they were completed, we've been able to learn a lot about learning curves and adaptations. Wildlife don't jump at the new opportunity to use these crossings once they're built, but as might be expected, they require time to find them, venture into them, and eventually feel comfortable and secure using them. And here we show the learning curves of coyotes on the left and deer on the right. And we expect the learning curve to consist of a gradual increase in use over time, followed by small fluctuations in use over time. And this is the pattern that we see here and what we've seen looking at 12 years of data for 8 large mammal species we have dated for. And last, long-term monitoring has proven extremely useful for the design, not only of monitoring programs and making recommendations on future designs based on sufficient monitoring durations. This graph shows the amount of grizzly bear use of the Banff crossings from 1997 to 2010. The point I want to make here is that if Parks Canada had only given us a 1 to 2 year period to monitor the Banff crossings prior to making recommendations for the design of future crossings on Phase 3B, we would have come to completely different recommendations than we made 4 to 5 years later in 2004. Those earlier premature recommendations would have been to build not only more but larger crossings than what we recommended in 2004. So a premature recommendation of that type would have increased the cost of the Phase 3B project by 2 or 3-fold. Education and outreach has been an important part of our research project, not only the transfer of technology to transportation practitioners and resources management, but to the general public and local decision makers. Using some of the better photographs from our monitoring work, we created posters, as you see here. They've been hugely successful in getting our message across about the importance of crossings and how effective they are. And some of the most interesting and really artistic photos were the centerpiece of an exhibit we put together at the White Museum of the Canadian Rockies in Banff. More than 19,000 people visited this exhibit, and it ended up winning a Banff Heritage Tourism Award in 2006. So now I want to take a minute to Now we have time to play a video. Yeah, I just wanted to mention that the research video footage, we don't use that for data, but we use it for outreach and education, and it certainly is lot more effective than showing a lot of histograms and graphs and numbers on a slideshow presentation. But when you're able to show video footage, it really gets people excited. So to end this part of the webinar, I want to discuss one area that is really ripe for more development, and that's the economics piece. Rob showed earlier how mitigation measures can pay for themselves. When we start adding multiple crossings, including overpasses, the price tag really starts to skyrocket. And as you can see from the list of costs in here, in slightly more than a 10-year period, everything has tripled or quadrupled in price. Overpasses have tripled in price, as have wildlife underpasses. Despite these costs, Banff National Park has paid a hefty sum to install wildlife crossing mitigation. 15% of the total TCH expansion cost in 1986 was dedicated to environmental mitigation, crossing structures and fencing. 25 to 30% of the total cost in 1997. And today's construction cost of roughly $240 million, 40 to 45% is dedicated to wildlife mitigation. So this is time for a poll question. How many wildlife overpasses do you think are found in the United States today? Just to see what you're thinking out there about how popular these things are, how abundant out there on the landscape.
All right, I'm going to close the poll and show the results.
Okay, well, it's a third of the respondents are actually pretty close. It's there's actually 7 in the United States today, so 6 to 10. There are about 32% of you. That's what you were guessing. Almost, well, let's say 40%, almost 50%, I guess, thought that there were more than 10. Which could be true, I guess, in a couple of years, because there are quite a few actually in construction right now. There will certainly be more than 10, 5 to 10 years from now, but certainly 5 years from now. And let's see, let's go on. Okay, I think there's time. This is the last question and answer. So if you have any questions, I'll try to answer those.
Sure. And again, any of the presenters, if you're more than welcome to jump in and answer this question. It says, you stated that most of the WVC occurred on roadways from 1 to 5,000 ADT. That's still a wide range, and 5,000 ADT isn't really considered low-volume roads. Typical low-volume rural roads are 400 ADT range. Could you provide more information, such as more about conflicts for 4,000 to 5,000 ADT, and what does the data show for 200 to 400 ADT?
I could go ahead and answer that, Rob, if you want. Try to answer that. Yeah, I noticed that as well. Typically the highways, the problematic highways are, generally anywhere from about 2,000, 3,000. When you start getting above 3,000 ADT up to 5,000, that's where those are certainly the more problematic highways for certainly when we're talking about large mammal vehicle collisions. Not these low volume roads that have less than 1,000 vehicles per day. But this range between 2,500 to 5,000 vehicles a day are problematic because there isn't this really disturbance effect from the amount of traffic on it, because it isn't like a 15,000 ADT. So you do tend to get wildlife coming to the highways and trying to cross the highway, but at the same time you have a traffic density that's relatively high, and it is risky for wildlife to cross those highways at those traffic volumes.
And last question before we move on, are there any examples or data for wildlife crossing related to railroad lines?
Well, there aren't any. Typically, even though roads and railways oftentimes are found together, I can think of just a couple examples. In fact, US 93 in Montana, there's a place where, no, in fact, that is an example. It's not an example. I'm not familiar with very many places where where the road and the rail has been mitigated together. Where I am in Banff, for the Canadian Pacific Railways, in some places is very close to the Trans-Canada Highway. And sometime in the past, they punched a culvert through the railway ballast, and it's literally about 50 yards from an underpass. And from monitoring that, we find that oftentimes wildlife will go through the underpass, but then they'll just climb over the railway ballast and over the rails, and not even use the underpass that's there for wildlife.
All right. Please feel free to continue to type in your questions. We'll take more questions at the end of the webinar, and if we run out of time, the presenters will follow up with you on email to your questions as well, and we will move on to the next portion of the presentation.
Okay. So in many ways, Banff is unique because it's a World Heritage Site. It's also a national park, but in the majority of cases, wildlife mitigation is not as easily supported or implemented outside of a national park setting. And a large part of this is due to the real and perceived cost of the mitigation and installing mitigation and maintaining it over the long term. Seeing the cost of these overpasses triple in slightly more than 10 years really started me thinking that if they continued to increase, that soon they'd cost themselves out of existence. And I didn't believe that the true cost was really so high, but really a lack of innovation was really what kept the prices increasing. So I wondered, could we really build these things more cost effectively? And why don't we get together some bright-minded civil engineers, some ecologists, economists, landscape architects, and see if they can generate new ideas and maybe even more economical designs for wildlife overpasses. And from that idea came, well, why not have a competition and get a lot of bright people thinking about this? Can we build them differently? Can we build them more cost effectively, and maybe at the same time generate some public attention about crossing structures as well? And from this, the art competition emerged, and this is what Angie's going to be talking about from here on.
Yeah, thanks, Tony. Before I get into talking about the competition, I wanted to get a sense from you all if you've ever heard about the ARC International Wildlife Crossing Infrastructure Design Competition. So take a moment there.
Okay, I'll close the poll and show the results.
Okay, well, it looks like we have a little bit more work to do. This is a competition that happened about a year ago, and we've been trying to share the innovations that have come out of it at a couple of different conferences and newsletter articles and the like, and I will be presenting at the TWS Wildlife Society conference next week, and so hopefully more of the natural resource professional realm of people will come to learn about the ARC International Wildlife Crossing Design Competition. So I'm going to share with you the origins and inspirations for conducting the first ever competition of its kind here in North America, the partnerships that formed during the course of the competition, the finalist teams, features of their designs and how they were juried, and I'll close with the overarching theme and goal of the ARC partnership, the pursuit of which continues even though the competition aspect is now over. So Tony's idea for the competition quickly drew support from the Woodcock Foundation in New York City and the Federal Highway Administration, and WTI contracted services with Ryerson University in Toronto and the Western Law Center, and we partnered with many other organizations to make the idea of the competition into a reality. And building partnerships was a key element to the competition, because not only did the partnership building process bring this issue of habitat connectivity to the forefront of our collective consciousness in a whole new and exciting way, really, but it also sparked collaboration and conversations between different disciplines, like engineering and landscape architecture, ecology and design, and also between organizations, both public and private, for the common goal of addressing a massively complex societal challenge of achieving sustainability while maintaining mobility for people and wildlife. So ARC was a two-phase competition held over the course of about 6 months. And phase one drew over 100 firms representing 9 countries. And they coalesced together as 36 teams who submitted. And in that phase, we were only looking for their qualifications and design approaches. And these 5 teams from New York, Philadelphia, Toronto, and Amsterdam were invited to continue on into phase 2. So the real-world site that was selected for the competition was Westvale Pass along I-70 in Colorado. That also is through the White River National Forest in Colorado. And phase 2 included the building of a small-scale 3D model like the one shown here to give us a sense of the team's vision of the next generation of wildlife overpass. And they also had to submit supporting panels and booklets to serve as interpretive aids for their design. The ARC competition sought innovation in feasible, context-sensitive, and compelling design solutions for safe, efficient, cost-effective, and ecologically responsive highway crossings for wildlife. It was a tall order. In the broadest context, ARC challenged its competitors to reweave landscapes for wildlife using new methods, new materials, and new thinking. Now, specifically, the ARC competition demanded attention to myriad criteria, everything from safety and load calculations, span and width dimensions that adhere to scientific evidence and legal criteria, specifications on cost, maintenance, land tenure, and rights of way, soil specifications. They had to give information about how they would mitigate for noise, light, vibration, and visual disturbances, how they would design exclusionary fencing, how they would work with native habitat, what their target species would be, where they would place viewing platforms, etc. They were also asked to share ideas on creative partnerships, community needs, and public engagement. So we have another desktop exercise for you here, where you'll have a chance to hear from the leaders of the finalist teams themselves tell us in their words their approach, philosophy, or unique responses to the ARC Design Competition Challenge.
We have tried to create a bridge that uses local resources and is sustainable. This low-tech approach, in conjunction with very local available material, can need a small amount of machinery and therefore energy. So we have a CO2 balance of the bridge superstructure, which is either neutral or even positive. The bridge body stores really more CO2 than was needed for production.
Seeing the FAA scurry around deal with bird strikes gives us an indication, I think, of how even a much smaller problem can get a tremendous amount of attention. Imagine the value that that crossing has. It certainly pays for itself many times over, and if you think of these costs are every year, so that $8 billion happens year after year. Why we're not building many of these wildlife crossings is more the question. If we don't start solving these problems now, I'm afraid they'll only get worse. The other opportunity is to show how successful a wildlife crossing can be at reducing the costs of animal-vehicle conflicts.
I think the unique aspect of the Olin plan is that it is modular and adaptable, not just with regard to the structure, but with regard to the landscape itself, so that, in fact, our design solution can become the 21st century solution for the federal highway system. And that is the excitement of the Olin plan. It deals with these two very different systems, one static system and one living system, but in the context of one form.
We pushed the boundaries by creating a very strong icon that we believed would inspire curiosity and help to bring recognition to the wildlife crossing. And we did that by using the color red to achieve this, because red is the only color that most animals do not perceive, but that human beings can see. In a way, it's sort of like a secret code by which you can communicate to people that we share the landscape with other living beings, and that beyond these roads there exist complex animal habitats that we must be mindful.
One crossing is not enough. You need a network. So we made a solution that is very cost-effective, and it can be used in all kinds of situations. It's very light construction. It has a repetitive design elements in it. It's an parametrical design, so you can reuse all the fabric formwork invented for that. And, well, it's a very sustainable solution, and you can use it on many spots.
So the ARC partnership is proud to celebrate the 5 finalist designs as a collective tribute to innovation in the name of wildlife crossing infrastructure. But every competition needs a single winner, I guess. So the ARC partnership enlisted these experts from pertinent fields to be our jury. And so they were given complete latitude to decide the overall winner. And while the jury was struck by the quality and innovation of the design proposals submitted by all 5 finalist teams, they felt that, quote, the winning proposal by HNTB Engineering with Michael von Valkenburg and Associates was not only eminently possible, it has the capacity to transform what we think of as possible, end quote. And that's what I think is perhaps the most powerful outcome of our competition. And my hope is that each of you participating in this webinar right now is rethinking the question of what is possible in your area. So the winning team called their design Hypar Nature, which is a hyperbolic paraboloid vault, and it would look like this. And the entire design was based on innovation in precast concrete design. So a typical bridge construction consists of different components as shown on the left. And as HNTB presented it, Hypar Nature is a bridging system that consists of precast modules that serve as abutment, beam, and deck all in one. And it could be created using commercially available straight line formwork as shown on the left. But then what they did was they took those slabs and oriented them in a different way to create a stackable modular form. And this single element is the key to cost effectiveness and speed of construction. The 2 modules are joined at the midspan, acting as a 3-hinged arch, which would eliminate the need for a central pier under the overpass. So that false work that you see in the center of this photo would actually be removed after construction is finished. And HNTB, the winning team, said that no on-site concrete work would be required, and that the modules are optimized for being efficient to transport, erect, combine, and recombine as needed. And then the same module, if you orient it differently, it could actually incorporate bike paths that are separated from traffic and the wildlife crossing above. So we might be seeing a preview of the next generation of wildlife crossing structure. It might be built along I-70 in Colorado or wherever such infrastructure is deemed necessary. And several DOTs have expressed interest in the ARC-inspired designs, and we promote the designers and the engineers and ecologists to talk to each other about the possibilities. And I guess the point is that whatever role we play, we should always be thinking of new connections, new methods, new materials, new thinking, and new solutions. So the ARC competition brought together great minds, as Tony envisioned, and provided the space for creativity on an issue that is often ignored or gets mired in issues of cost and complexity. And now that the competition is over, the mission of the ARC partnership is to strive for implementation of cost-effective wildlife crossing infrastructure to benefit humans and wildlife wherever it's needed. So much, if not all, of the information I've shared with you about the competition can be found at www.arc-solutions.org. So thanks for listening about that. And I'd be happy to take any questions you have about ARC. And in the meantime, I just wanted to point out, though, that here's the list of references that we used in this presentation. And this next slide shows also other resources that Tony referred to, the Wildlife Crossing Structure Handbook, and then also the manual that Rob alluded to about wildlife vehicle collision reduction, and then also a link here to the ARC Solutions website.
And I'll remind everybody that all of these resources, as well as the PowerPoint presentation, are available in the handout section of Live Meeting. You simply need to download it, and you'll have availability to all of these links and all of the resources and references that have been mentioned. And we're going to hand over the presentation now to Sandra Jacobson with the USDA Forest Service. Sandra?
Good afternoon. I'm happy that you're all here, and can you hear me?
Yes, we can.
Good. Okay. So with the remaining just a very few minutes, I'm going to run through a super brief tour of some other resources specifically for federal land management agencies, and those hopefully will, whoops, wrong direction. These three items: training opportunities, websites, and videos. And the first one is a short course on wildlife and highway interactions, and this course has been offered for a number of years. We will have one in 2012 in August at the Sagehen Creek Field Station near Truckee, California. And this is primarily for wildlife biologists, engineers, the transportation community. We talk about issues particularly pertinent to federal land management agencies. In addition to that, some policy background and funding sources and how to get those projects, those mitigation projects, especially that we want to do, done. The second training course is called the Eco Highways Workshop. And in this case, we've found that there is kind of a common theme where we have misunderstandings of who's doing what when. And so this is an attempt to bring together all of the interagency folks that are working on a project, a highway project development, and get them on the same page. And it uses a cadre of experienced natural resource managers and transportation planners, and it goes along to explain some of the roles, responsibilities, and missions that vary among the agencies. We also incorporate mentors and have some ongoing support. That workshop is on-site and on demand. You can contact me to have that. The next item is a website, and some of you may have heard of the Wildlife Crossings Toolkit. It has been around for quite a while, but now it's been renovated and republished, and the content is now primarily oriented towards federal land management agencies, with a lot of resources for the land managers who are faced with highway issues, and particularly wildlife issues, but not exclusively. It includes a lot of case histories, mitigation measures, current events, and in particular some things that are useful for federal land management agency staff. There are some example EAs, MOUs, analysis documents, and other decision support tools. And the URL is down there at the bottom of the slide. And then we have two videos that are upcoming. We're very near to launching both of these. The first is Fish and Wildlife Service and Forest Service have collaborated on creating a really nice video on just one segment of the Innovative Approaches short course, which is 3 days, as a course, but it's condensed into a 1-hour video, and that focuses on wildlife crossing structures mostly. A study guide is going to be available with that also, and that'll be probably available in January. And the last thing I want to talk about is a video that is targeted towards helping employees of federal land management agencies in rural areas find out what the highest risk driving situations are with regards to deer vehicle collisions and how they can reduce the likelihood of those collisions happening. And that again is going to be available here in the coming months. And with that, that's really a whirlwind tour, but there are some resources out there. Thanks for being on the webinar.
Thank you, Sandra, and thank you to all of our presenters today. We do have a few questions as we end the webinar today, and any one of you, please feel free to jump in and answer the question. The first one is, have there been any suspension design overpasses constructed?
I'm not aware of any. Are you, Rob or Angie, Sandy?
No, but it made my eyebrows go up.
Yeah, they should have entered into ARC, right?
Yeah.
Great ideas come in the form of questions. And the next question is actually for Tony. It indicates you've stated human use of wildlife crossing structures should be limited. Given the high cost of these structures, it could be more palatable for decision makers to allow for multi-use. Are there any studies that show that there are determining factors to wildlife by having humans use it as well?
Yeah, there are some studies that show that the greater amount of human use you have at the crossings, the less likely you'll have wildlife use, not just some of the large carnivore species, but also the ungulate species like elk and deer. Yeah, I understand the situation. If you can, I think a lot depends on where these structures are going, and certainly what the type of species or the focal species are around the site. In some areas that aren't too far removed from areas of human settlements and things, there have been overpasses built, and even underpasses have been able to be constructed mainly because they allowed for some human use, whether it's horse trails or just bike trails or something like that. And that generally isn't a problem. If there are species that are fairly habituated to humans, the coyotes and things like that, deer use these things as well. But certainly if there's species of conservation concern, species which are a little bit more sensitive to human disturbance, then you'd probably try to separate humans from wildlife at some of these structures. But otherwise, mixed use underpasses or overpasses can be a good way to go.
Great, thank you. And that actually looks like it's it for the questions for those people who are still online. There were a few questions that people asked, and they unfortunately had to leave the webinar. We have records of those questions, and we'll have the presenters follow up with you. Again, thank you for participating in the Paula Sarbanes Transit in the Parks Technical Assistance Center webinar. I'm going to leave you now with access to the TripTac website so that you can view information about any upcoming events, any new resources that are available. Thank you so much for your time, and once again, thank you to all of our presenters.